Hi everyone, my name is Stephane Schwarz. I am a master degree student in computer science at the University of Campinas, Brazil, and I will present to you the Emet algorithm, a short for embeddings from multilingual-encoder transform for fake news detection. This is a joint effort with Antonio Teófilo and was developed under the supervision of Professor Anderson Rocha. Briefly, our method explores multilingual embeddings that take into consideration the semantic knowledge from preceding trustworthy news and the use of rich comments to detect misleading content. Social media networks have changed the way that people interact with the world. In 2019, a demographic study from Pew Research Center has shown that 7 out of 10 Americans use social media to share information and engage with news content. However, the problem was that in the last years, social media have been used by government agencies and political campaigns to shape public opinion and divide societies online by polarizing news and text messages, as demonstrated by Oxford Internet Institute. Still, we cannot measure the real impact of this phenomenon in prior elections. In view of that, we propose a deep learning-based end-to-end framework for the identification of fake posts on social platforms as a consequence to mitigate falsehood spread. In order to keep consistency with the problem statement, an important question that we must ask is, what is fake news? Despite there exist different definitions, in this work, fake news is a made-up story with malicious intent. In the examples, we can visualize some characteristics of a made-up story. For instance, real images are out of the context, synthetic images linked with unreal events, and fake images associated with real situations. As a natural outcome, several researchers started to work over the theme of understand and mitigate hoaxes spread in microblogs. Castillo et al. Presented a heuristic-based approach in which they regarding 4 features category: the user, from the message, and from the propagation tree. Teófilo and collaborators focused on authorship attribution to help in the identification of fake news. Q et al. Explored the advantage of neural networks to learn multimodal representation of data. In this case, they consider not only the textual data, but also the visual domain. Despite the power of this method, none of them consider the semantic interpretation of the text message. And then, based upon sayings of Jesus, then we will know the truth, and the truth will set you free. We hypothesize that there exists a strong correlation between the post message, their comments, and past trustworthy news linked with a specific event that highlights whether a post is real, false, or unknown. In this context, our goal is to learn a model F that can label every social media post T related to a particular event E, taking into account not only the post itself, but also the comments C and all reliable news pieces N retrieved from traditional news source, considering a set of keywords key. In other words, given a set of social media posts related to a global or social impact event, we generate some keywords and search in reliable news source reports associated with the event concerned. An important point to observe here is the 0-hour events, or in other words, event that just happened. Probably there will be no credible news to be applied in this case. As an alternative to this is to consider information from similar events happening in short range of time, or utilize historical data of the region. The basis of our dataset are two social media verification dataset from Medieval Challenge that consists of a bunch of Twitter posts from 2015 to 2016, all of them related to 35 social media impact events covering 6 different languages. And to obtain the tweets comments, we developed a web scraping application which uses the tweet ID to find the required post. Unfortunately, a lot of tweets are removed from the platform, and as a consequence, only 3% of the entire dataset is available to recover the replays. But it was enough for our experiments. Similarly, we recover trustful news for each tweet using the keyword capture from the text post. And to prevent training and test overlap of the news samples, we used the BBC News on the training set and the Reuters ones on the test stage. The train and test column are the real number of unique tweets on dataset. On the other hand, the last two columns are the results of the news sharing process. In general word, it refers to the number of tweets times the number of retrieved news. As I mentioned earlier, the network receives 3 different text inputs in parallel, remembering the post, all concatenated comments, and the reliable news. We have chosen to concatenate the comments because after some experiments, we didn't note a significant improvement in the model performance. Then we prefer to concatenate comments and save some computational power. As you can see on the figure, to deal with 3 inputs, we first represent each text piece as a unidimensional signal or sequence of characters, and then we project each transformed signal on an latent semantic space based on transformers to get a more representative characterization of this content. This space projection was learned in a multitasking and multilingual scenario, which makes our model language invariant. Afterward, we apply 5 one-dimensional convolutional features over the projections to standardize the processing operations. The resulted feature volume are flattened and concatenated to assemble the input of the final convolutional layer to capture short and long-range semantic similarities. After that, a sequence of 1D convolution, max pooling, and fully connected layers are applied over the last feature volume. The intuition behind this structure is to capture intrinsic syntactic and semantic patterns among the 3 input sentences that they are far apart from each other. Finally, a set of 1D convolution followed by a fully connected layer and a soft max distribution probability function complete the network topology. The choice for use fully connected layers instead of convolution is because convolution is a local operation, while fully connected are global operation. And considering that we aim to capture agreements and disagreements among the merged messages, global operations highlights first and the second order feature easily. In order to grant for the test stage general characteristics of each class acquired on the test stage, we adopt a new ensemble method. As you can see on the animation, just for example, we will consider only the comments input, however, the same intuition works for the others. The method is organized in 2 steps. First, on the training stage, we get the average of all feature vectors after the embedding layer, considering this sample label. And in the end, we have 3 new vectors that are the average feature volume of each input sample on the training set. After that, on the test stage, for each input sample, we generated 3 others that are the sum of the meaning feature vector of the 3 classes of interest obtained in the last step, with the sample feature vector of the embedding layer. The final prediction label is defined through the majority voting over the three classes. To better evaluate the proposed framework, we raised three issues. The first one is how the embeddings from Multilingual-Encoder and the usage of new spaces improve the identification of misleading content on social media. To answer this question, we compared the results of two experiments with the latest state-of-the-art result. The baseline approach to know the two bottom lines are a deep learning-based model performed in a monolingual scenario and didn't use any auxiliary textual data to detect misleading content. In our network, we removed the comments input layer, as you can see in the image below, and tested with two dataset arrangements. One, considering unchecked news, is when we don't know if the news and the post talks about the same subject. And you can see in the table, our method outperforms more than 20% of the baseline. The other experiment considers only manually checked news. In this case, we know that all news associated with the post talk about the same topic. And now we got a significant improvement against the others. The other issue is how the comments contribute to improve classification performance. And in order to answer this question, we incorporate the tweets comments into our model, as you can see in the image. And in the table is the CNC line that we use to compare with the previous result. Look at the performance increased by almost 1%, which is a promising value, taking into consideration that only 3% of the whole data set has comments and the others didn't. The last issue is how the embedding model captured general information to better model the test set. Now, we just performed the ensemble method and compare with the already mentioned experiments. As you can see on the CNCE line, the model produces a modest reduction in terms of precision, recall, and FIUM score. In summary, we believe that Emet networks helps to address the problem of fake news detection on social media platforms in a multilingual scenario. For future works, we will explore the addition of multi-domain data, like text and images in the same solution, since it can boost the model performance. I would like to thank you, Icassp, for the opportunity to present my work, and also Movely, Wave, and FAPESP for the financial support, and our Recode team.